Hello, calculus students and general seekers of truth. I want to make this video here on this specific problem because there are some subtleties to it that I think it's important to focus on. This is number 12. Okay, this is number 12 in January of 2017. The multiple choice question. Okay. So the multiple choice question that I gave you, this is number 12 in January 2017. It may be different in other years, but this is made specifically for that class. Okay, so find the solution of the differential equation. So we do what we normally do, separate the variables. 1 over y dy is equal to secant squared x dx. Integrate both sides of these. On the left, we get the natural log of y equals the tangent of x plus a constant. And then if you continue to solve, you get y is equal to e to the tangent of x plus a constant. And if you go on after that, we could say that this is equal to e to the tangent times e to the c, which itself is just another constant. So this is what we typically do, and we get that. Okay. Then we are going to take y and set it equal to -1 and x and set it equal to pi over 4 and solve. So -1 is equal to some constant e to the tangent of pi over 4. Okay. Now you can see that this already presents a problem. Once we figure this all out, we get that, oh, maybe it doesn't present a problem. We will get -1 is equal to c e to the first power. So then what we have is -1 over e -1 over e is equal to c. So our final equation is that y is equal to -1 over e, e to the tangent of x. And most likely on a multiple choice, you'll see that y will be simplified down yet further. So this is really negative e to the -1. That's this part right here. E to the tangent of x. And then y is equal to negative e to the tangent of x minus 1. Since we can combine these two, they have the same base, and that is our final answer. Okay. Now I want to retrace our steps a little bit. So this is the correct answer. I want to retrace our step a little bit to another possibility. Let's say that you were working, you come along very well, and you got to this point. Let's say you didn't simplify and pull the c out in front here, and you try to solve it from here. And from this step, you would say that -1 is equal to e to the tangent of pi over 4 plus a constant. And then we try to solve for c here. And you solve for c by saying that the natural log you take the natural log of both sides. The natural log of -1 is equal to tangent of pi over 4 is just 1 plus c. The natural log of times the natural log of e. Okay, so you took the natural log of both sides. This would cancel, and you would end up with a very major problem here. So you see here that the natural log of -1 is not defined. The natural log of -1 here is not defined. It is a non-real answer. And many people get stuck here. If I was writing a multiple choice, I would make sure that undefined would also be a solution, one of the choices, just to catch people off guard there and catch them in that trap. So you see that if you actually it actually matters whether you solve it through and you carry the C out to the front, or if you try to solve it in the intermediate steps. Okay. Now, if you did try to solve it in the intermediate step, there is a correct solution, and it has to do with this natural log here. Something that we often forget is that the antiderivative of 1 over y is actually the natural log of the absolute value of y. So don't forget that. So that when we try to solve for c using at this point, we get the natural log of the -1 of the absolute value of -1 is equal to the tangent of pi over 4 plus c. Okay. Then we can say that the natural log, the absolute value of 1 is just 1, is equal, this is 1 plus c, and the natural log of 1 is just 0. This is equal to 1 plus c. Therefore, c is equal to -1. Okay. So we have c equals -1 here, and if you take -1 and plug it into this point and continue to solve it through, you would in fact get this final answer. Okay. So the subtlety to this problem is that you could solve it several different ways. You could solve the exact solution several different ways, and depending on which step you decide to use to solve it, you may get a different answer. In some cases, an incorrect or an undefined answer. So if you carried it all the way through and simplify, and the trick is you have to simplify this constant as far down as possible, then you use that version to solve, you would get the correct answer. If you started from the beginning and you try to solve c from there using the correct antiderivative, you would get the correct answer. But if you try to take some intermediate step, you will end up with a problem. Okay? And really, the issue here is that this should also have an absolute value there as well. Okay? So if you take it from this point, I'm just going to solve from this point here, just so that you can see where that's headed. Okay? So this is really saying the natural log of y is equal to the tangent of x minus 1. And keep in mind, this is really the absolute value, right? So y is equal to e to the tangent of x minus 1, the absolute value of y, that is. Okay. Now, when I plug in pi over 4 in here, I get e. I get e to the 0 is equal to the absolute value of y, right? And this is just y equals 1. So that means the absolute value, there's two choices. There's the negative choice and the positive choice that I could plug in here. So what I need to do is say that it's y equals negative e to the tangent of x minus 1. Okay, so this is such a big, not big, but this is such a subtle part of the problem that it often catches people off guard. And we may not have seen enough examples of this in our work. So I wanted to make sure that you see an example of this so that you could not only get the right answer, but understand the rationale behind each of the subtleties. Thank you for watching. As always, ask if you have questions. Have a wonderful day.